day, grade 12 learners. Welcome to today's Agricultural Sciences lesson. My name is Amanda Fumba. This program is funded by the Northern Cape Department of Education, broadcast by Pagama Research and Development. We are focusing on examination questions where we are going to look at subtopic, which is energy value of feeds, which you find it in paper 1, question 2. So it is part of the topics that we find in question 2. So we need to check all the avenues. How is this question normally asked in the previous question papers? So we need to look at our examination guidelines, and it is stipulated on page 20 that the energy value of feeds, we need to look at the following points. We must be able to define the terminology in energy value of feeds. When we talk about this energy, what is it? What are other terms regarding these energy values? Secondly, we have to be able to know and name the units in which energy value is expressed. How is energy expressed? So it is important to know the units. As long as you deal with energy, you must know the units for energy, and when you will be doing your calculations, you must know at all times you have to attach the units to know that you deal with energy. And thirdly, you must be able to identify and draw energy flow in feeds when it is necessary, or you must also be able to interpret these energy flows when given, whereby you're supposed to fill in or complete it, and whereby you are asked about how energy is lost and the ways in which energy is formed. So in this topic, what is needed from you? You are expected to have your working calculator and make sure that it is functional. Secondly, you must be able to understand the units and know the units in which energy is expressed, whereby we talk of joules. Energy is measured in joules. Understanding terminology and schematic representation of feed energy flow, whereby you must understand when you are required to draw, you must be able to do so. When you are required to interpret the information given, you must be able to do so, as you will have to apply the knowledge that you have on this topic. Let's look at terms that you need to understand. We cannot just talk about gross energy if you don't know what is energy. The energy is that ability to do work. It still remains the same way as you were told in your lower grades. Once you talk of energy, it has got to do with the ability to do work. And where do we get this energy from? We get this energy from the food that we eat, and the animals, they get this energy from the feed that we are giving to our animals. By the terms that you are going to be assessed on in your examinations, you need to understand this term gross energy. When we talk of gross energy, we are referring to the total energy provided by the feed when it is completely burnt, which means when it is oxidized. So we are talking about gross energy in totality on that feed you are going to give to the animal. And when we'll be talking of digestible energy, what are we referring to? Digestible energy is the gross energy minus energy lost through feces, which means for you, in order to get gross energy, in order for you to get the digestible energy, it is digestible energy is equal to gross energy minus feces. Okay, that is the simplest version of defining what is digestible energy. Digestible energy is equal to gross energy minus feces. And when you define metabolic energy, it is the gross energy minus energy lost in feces, that is an error, which is made in feces, which is lost in feces, urine, and fermentation, feces, which are gases, gaseous end products. So all in all, we talk about the energy that is lost in feces. It is lost in urine and fermentation feces. And we talk about these gaseous end products. What are these gaseous end products? We are looking at carbon dioxide. At the same time, we are looking at methane. These are the gases we are looking at. So for digestible energy to be there, or for metabolic energy to be there must be digestible energy, whereby you are going to minus feces, you are going to minus urine, and also gaseous exchange, which is methane and carbon dioxide. And thirdly or fourthly, we look at net energy. Net energy is the gross energy minus energy lost in feces, energy lost in manure, energy lost in urine, or energy lost in gases, and also energy that is lost through heat. Okay, so in order to have gross energy, gross energy, we say gross energy, you lose feces. That is the first thing. So this is the first way in which energy is lost. It is lost in a form of feces from the gross energy in order to get digestible energy. Once you have once the plant animal has digestible energy, it's not able to utilize it until the animal loses energy in the form of gases and urine. And this gaseous exchange that we spoke about previously, which is carbon dioxide and methane. So once feces are lost, it is no more gross energy. It becomes digestible energy. Digestible energy is when carbon dioxide and methane is going to be lost together with urine, and then which changes the status of digestible energy into a new type of energy, which is metabolic energy. This metabolic energy is not available to be utilized by the plant too. It is going to lose energy in a form of heat. And then when it loses energy in a form of heat, it forms the fourth energy, which is net energy, and which is the one that is available to be utilized by the animals for maintenance purpose and also for production and reproduction purpose. This is the energy that can be utilized by an animal. All in all, it is the energy that is available. Okay, so you'll be asked about the types of energy. You have the gross energy, you have digestible energy, you have metabolic energy, and net energy. When you are asked about the ways in which energy can be lost, energy can be lost in a form of feces. That is A. Energy can be lost in a form of urine, which is B. And it can be lost in a form of gases. That's why I break down these gases, because it is important for exams to know which gases are we referring to. And these gases, remember, they are the ones that they cause bloating if they are not released in the reticulorumen. Then the fourth way in which energy is lost is in a form of heat, because the animal will sweat. Okay, then these are the ways in which energy is lost, and these are the types of energy. When we talk of gross energy, we talk of digestible energy, we talk of metabolic energy, we also talk of net energy. They are the types of energy. You need to note that, and it is important for you to know. The greatest part of feed is used for production of energy so that it can be available. The amount of energy in feed is expressed in joules or calories. So hence we say the joules, they are the unit measurements for energy that we are talking about. So let's check our DBE question papers, or let's check some of the questions that talk about this energy value of feed. So I sampled few of multiple choice questions. The gross energy value, you know that in your multiple choice questions, you are choosing only the best option. You are given 4 possible answers and the 3 are the distractors. Therefore, you need to choose only the correct one by writing a letter, not rewriting the statement. So let's look at 1111. The gross energy value of a feed minus energy lost through manure, through urine and gases. What are we looking at? So we say gross energy. So it says it's gross energy value of feed minus the energy lost in manure, energy lost in urine and gases. Then what do you get? Gross energy is equal to, you are saying gross energy value of feed is minus the energy lost through manure, GE minus manure and U plus urine and gases. Then when gross energy loses manure, it forms digestible energy. So which means it's wrong because there is also urine and gases. Gross energy minus manure, it gives you digestible energy. And digestible energy will lose energy in a form of gases and urine. Then we talk of metabolic energy because this is what we are given. Net energy and gross energy becomes wrong, which means the most possible answer will be B. The metabolic energy of the feed is equal to the gross energy of feed minus energy lost in the metabolic energy. And what I want to tell you, you must know them in order, that you have gross energy, you have digestible energy, you have metabolic energy, you have net energy. And you know, in order to get this one, there must be manure or feces lost in order to have digestible energy. So digestible energy, it will lose energy in 2 ways, in the form of urine, at the same time in the form of gases that you must know their names. And then it will form metabolic energy. Metabolic energy, it will lose energy in the form of heat in order to form a net energy that will be available to be utilized by the animals. Then now, let's look at the statement that we are given. You have this information. Metabolic energy, which means your focus is here. Metabolic energy of feed is equal to the gross energy of feed minus energy lost in manure, lost in urine, lost in body heat. That is incorrect, which makes the statement not to be correct. Gases, urine, body heat, it makes it incorrect. Therefore, which one will be correct? It will be manure, it will be urine and gases in order to have this metabolic energy, which makes it the possible answer. The last one is not correct because of the body heat. So you need to collect your information when you work with your multiple choice questions. Therefore, your answer will be C. So your correct answer is B, your correct answer is C. Let's look at short questions that talks to this energy value of feed. You must expect to be given a schematic representation at some point which will show the feed energy flow as it is on this 2.3. You are given gross energy which is 18.5 mJ per kg. And this gross energy loses energy in feces in this amount, which is 7.32. And it forms this type of energy that is not mentioned. And it loses energy through urine and methane in this amount. And it forms B that is not mentioned. B loses energy in the form of heat in this amount, and it forms C, which is also not mentioned. Indicate the letter representing the following types of energy. Energy available for maintenance and production. The instruction says give the letter. The one that is available for maintenance and production. Remember, we mentioned an animal is given this total of energy. This is not available due to these losses. This is not available due to these losses, which means it is the only one that is available for maintenance and production. Energy that remains after microbial digestion by ruminants. Which energy will be that? Calculate the amount of energy in A. The amount of energy in A that the animal will get from the feed. Okay. Then in order to do your calculations, you need to know that you work with gross energy. In order to find A, your gross energy, you are calculating A, which means your A is equal to gross energy minus feces. Okay. Then how much is your gross energy? Your gross energy is 18.5 mJ per kilogram minus the feces. The feces that you are given here is 7.32 mJ per kilogram. It is important to always write units as you are given to qualify that you are working on energy. So you have to say 18.5 minus 7.32, then you get your answer. And the answer that you are going to get will be 11.8. 11.18 as you are calculating mj per kilograms. Then you get your 2 marks. How is this 2 marks allocated? It will be allocated on showing your formula that you are going to give and also your findings. Indicate the letter, or we worked on C, and you also worked on your gross energy minus energy in feces, that is your A, and then you have calculated this. That's how it is allocated. Energy that remains after microbial digestion by ruminant animal. Why are we talking about this microbial digestion? We said gross energy minus feces, you get digestible energy. And this digestible energy is whereby it will lose energy in the form of urine and methane. And the methane, which also goes together with carbon dioxide, which will form bloating after microbial digestion. Remember, microbes or microorganisms, they digest cellulose. And when cellulose is digested, the volatile fatty acids are formed, and that's why we are talking of these gases that are also formed that need to be released. If not released, they lead to bloating. That's why it qualifies for B, because it is after that, as the question talks about after microbial digestion. Let's move on to the second question. The value of the feed depends on the energy content that remains after all metabolic processes have occurred in the body. That is the statement that makes you to recall the content. Name the energy that is important for production and maintenance. You came with gross energy, digestible energy, metabolic energy, and net energy. And you need to know amongst the four which one is important for production and maintenance. Give 2 reasons why it is important for the farmer to know the energy value of the feed. Why do we have to deal with this topic? It is important. So the energy that is important for production and maintenance is net energy. Reasons why it is important for the farmer to know the energy value of it, or you'll be asked to advise your friend why is it important to know, as a new farmer, to know about the energy values of feed. To determine the type of animal diet, so that you know which diet must you give to this specific animal. To determine feeding standards, you must determine the feeding standards, meet animal requirements at different stages of production. Also to determine the ration formulation. So these are the reasons why it is important to know about these energy values, to know the type of animal diet. You must understand the feeding standards. You must understand different stages of production of an animal to make sure that you meet the relevant requirements. And you also understand the ration formulation. When you formulate rations, you must know what you need to mix and what not to mix. Let's move to the third one. The information below indicates the daily metabolic energy requirement for maintenance of cow as per live weight. You are given this data where you are given the live weight of cow in grams. Metabolic requirement in mj per kg or per day. mj per day. You are given the live weight of cows from 350 grams to 600 grams, and you can see there is an increase from 350, 400, 450, 500, 550, 600. And when you look at metabolic requirements, as the live weight increases, so also the weight increases. So the metabolic requirement, the needs that requires, they lead to an increase to the weight gain. So present the above information above in a form of a line graph. Then now you know that at all times when you are asked to draw a line graph, you have 6 marks in your pocket that you bring along as you come into your exams. That is the free mark at all times. In all your question papers, you must expect to draw a graph, and the mark allocation for graph is 6 marks. You need to know what is expected. You need to know that you must have a correct type of a graph. Correct type of a graph. At the same time, your graph must be labeled and it must be calibrated. When you talk of calibration, you talk of scaling. It must be well scaled. You must use the correct scaling. At the same time, that is your x-axis and your y-axis must be labeled and calibrated. That is the third mark. And then the fourth mark, it must have units when you are given. If you are given 1, use 1. If you are given 2, you must use both of them to qualify for 1 mark. At the same time, you must be able to, you must have a heading. That's supposed to be the first one. The heading, and your heading at all times must have both variables. And lastly, we are looking at the plotting. And your plotting, your examination guidelines, it states that at least it must be 80% correctly plotted. Okay, so that's how this 6 marks is distributed. They use the trend of metabolic requirements per live weight of a cow. The trend of metabolic requirements. And I want to highlight this. Once you have drawn your graph, you must expect a follow-up question, which will be on a trend, or it will be on a relationship, or you have to do a comparison. That will be a follow-up question, and most of the time is 2 marks. The main aim or what you are being assessed there is your interpretation skill. Are you able to interpret the information that is in your graph? Okay. So the trend of metabolic requirements per live weight of a cow. Is it increasing or is it decreasing? As metabolic requirement increases, also the weight gain increases, or the live weight increases. Calculate the metabolic energy requirements for the maintenance of a cow with a live weight of 400 kg. 400 kg in 5 days. And in 1 day, how many? Is 23. So now you need to calculate for how many days? For 5 days. Therefore, how are you going to know for 5 days? You have to say your 23 times 5. And when you say that 23 times 5, what do you get? You get your 115. Okay, so the metabolic energy requirement for maintenance of a cow with a live weight of 400 in 5 days, it will be 115 mjs per day, or for 5 days. And it will be 115 mjs. Name 2 reasons why it is important to calculate the energy value of feed. Remember, we dealt with it to know the type of the diet. At the same time, you have to know the feeding standards and the ration formulation. If you check at your graph, 6 marks, I indicated the heading. The x-axis must be labeled and calibrated, and the y-axis must be labeled and calibrated with the metabolic energy requirement. Is it the correct type of a graph? Is it accurate? So in this accurate, we are looking at plotting, and then the correct units as you are given. So how do we mark? It's a correct mark for the heading. It's a correct mark. It is well calibrated. And when you do your calibration, you know at all times you start with your 0. And at all times you must avoid connecting your line with this y-axis, as this is y-axis. It must not start on the y-axis. Hence, you can see it has started where it's supposed to start. Don't join it, because you'll be losing marks for your correct plotting. So you have a mark for it is labeled and well calibrated. Use a proper scaling. So live weight of cows, then you get a mark because it is well calibrated. And then the type of graph is already having, you already have a mark. And then what are we looking at? We are looking at units. We can see the mgs, we can see the grams, then you get 1 mark for the unit. 1, 2, 3, 4, 5. And then the last mark for accurate, which is the plotting, and it says at least 80% must be correct. So all of them are correctly plotted, and then that's how you get your 6 marks. Please make sure you always get that 6 marks, because it's a free mark. You are assessed a graphic skills. And then secondly, you'll be assessed, are you able to interpret what you have drawn or what you were working on? They use the trend of metabolic requirement per live weight of a cow. As I already indicated, metabolic energy requirement increases with the increase in live weight. As the metabolic rate increases, then also the live weight, it also increases. You were also asked to do the calculations, so we dealt with that. We said metabolic energy times number of days. Metabolic energy requirement is 23 mjs per day, and the number of days is 5 days. That's why we had 115 mj. The importance of calculating energy, we have animals' diet, the feeding standard, and the ration formulation, and more others. Let's look at 2.4. 2.4, you are given a table which shows the gross energy value and the energy losses after 1 kg, which is this one, after 1 kg and after 5 kg of a feed were consumed by a farm animal. Gross energy for 1 kg was 18.5. for 5 kg was 92.5. So the energy lost, it varies per kilogram. For per kg, 8.5 of manure was lost, 1.2 of urine was lost, 1.8 of energy was lost in the form of heat, and 2.5 was lost in the form of gases, the gas which is a methane. Okay, with 5 kg, the amount of gross energy started at 92.5. 42 was lost in the form of feces, which is manure. Urine lost, energy lost in a urine at 6 joules, and then the energy lost as heat was 9 joules, and then the one that was lost as methane was 12.5. So you need to understand and respond to the question that is asked. Indicate the energy lost in manure if the farm animal consumed 5 kg. This is a free mark because you just extracted from what you are given. So you go for your 5 kg of feed. This is your 5 kg, which means your response is on this column. Indicate the energy lost in manure. You go to the energy lost in manure, then you are able to write. Your answer is a free mark. Identify the gas with the highest energy loss in the table above. Do you understand which gases are we talking about? So manure is not a gas, urine is not a gas, heat is not a gas, and the methane is a gas. So you must identify a gas with the highest energy loss in the table above. It is methane. You just write your methane as your answer. Calculate the amount of energy that will be available for growth and production in 1 kg. And at all times, you must show all your calculations to play safe. You must show all your calculations. You have this 1 mark, you have this 1 mark. In order to have these 3 marks, what is expected from you? As you are calculating the amount that will be available for growth and production. So you need to, on your 1 kg, you start from your 18.5. Your 18.5 is minus all of this. So you have to minus your 8.5, you have to minus your 1.2, you have to minus your 1.8, and you have to minus your 2.5. So you need to add your 8.5 plus 1.2 plus 1.8 plus 2.5. It gives you 14. So all in all, you'll say 18.5 minus 14. So 18.5 minus 14, it gives you 4.5 J's per kilogram. All right. Then now you'll be able to get your 3 marks. How is it allocated, these 3 marks? You have said net energy is equal to gross energy minus energy lost in manure plus in urine plus as heat plus as methane. We started with this one. So in order to have your net energy, you have done this one. You have shown your calculations. You have shown us how did you get your 14 joules. So 18.5 minus 14 joules, you get your 14, your 4.5 joules. That is free. So always play safe, show all your calculations. We move to the next one. The diagram below, it shows the energy values of a feed. And if you check the mark allocation, it varies from 5 to 8 marks. Okay. The gross energy, which is 19 joules, has lost energy through feces. Digestible energy has lost energy through urine and fermentation gases. in order to form the A that is not shown. And A loses energy in this form, which is in a form of heat, in order to form a net energy. Then we have a metabolic energy. Okay. Calculate the energy value represented by A, and the instruction says show all your calculations. So calculating the energy value represented by A. So when you calculate A, and your A you know is your metabolic energy. Metabolic energy, in order to have your metabolic energy, is gross energy minus, one will say gross energy minus dE minus urine minus fermentation of gases. All right. Then your gross energy, how much it is 19 joules, minus your dE. Your dE, remember, you have 7 joules plus your 4 joules. 7 joules that you get from energy through feces, and also minus is urine, is feces, urine, and fermentation of gases. 7 minus 4 plus 4. 7 plus 4, it gives you 11. So all in all, use your calculator. Don't take for granted. Say 7 plus 4, you get your 11. It means that 19 joules minus 11 joules. And how much are you going to get? 19 minus 11, you are going to get 8 joules. That will be your answer. You have shown that 7 plus 4 is 11. That's why you were able to say 19 minus 11. Identify the energy loss in B. We already dealt with that. So once you get the information, just apply your mind before you check your questions. Give 2 reasons why energy C is important for farm animals. It is important because it is a response that is net energy. Energy is important for what? For maintenance. At the same time, it is important for production and reproduction. Okay. We have done that. On 19 minus 7, we used this one. We say GE is lost through feces, urine, and gases. You get your MJs, your joules, which is your metabolic energy will be your 8 joules. The energy which is lost through heat. So this net energy is used for maintenance, for production, for reproduction, at the same time for growth, and also for physical work done. Those are the functions of net energy that is available to animals. That takes us to our reflection. We need to reflect on whether did we do as per examination guidelines. We define terminology in energy value of feeds, where we discuss the gross energy, we discuss the digestible energy, we discussed metabolic energy and net energy, and why net energy is important. We named the units in which energy value is lost, and we indicated energy values are expressed, not lost. We named units in which energy value is expressed, that is in joules. We identified and drew energy flow in feeds, and we also did calculations when necessary. So it means we have looked at examination guideline and we are ready to respond in any question that has got to do with the energy value of feeds. That takes us to the end of our lesson. Thank you for watching this lesson. See you next time. Good luck and goodbye.